Okay, so your question will be, a parachutist jumped off from the aeroplane on a regular training section. When his parachute opened, he traveled vertically downward with velocity v naught. The velocity of the parachutist at the time t minutes is v, and his acceleration is given by dv dt equals to g minus alpha v. So your story timeline here involve two two quantity. One is about your t, one is about your velocity. So at the beginning, t naught, your velocity will be v naught. Alright, so the t here is referred to the minute. So g is an acceleration due to gravity, and alpha is a constant, means that this 2 is a constant. G and alpha is a constant. Alright, so your variable here only v. To solve this, so the solution v in terms of time. We can do this by separable method. As you can see, your expressions here only involve variable v. We don't have variable t come in. So therefore, the whole statement of the v we move to left hand side. Then we integrate both sides. Alright, so integrate fraction. It will be give you ln over coefficient of your unknown. Your unknown here is respect to v. So your coefficient of v is negative alpha. Then for the right hand side, integrate 1 respect to t will be 1t plus c. So simplify here. Alpha t minus alpha c. Then unlock your logarithm. E will be power of negative alpha t. So negative alpha c. Alright, simplify the power here. E negative alpha c. It can be, make it at a constant. Why we can make it to the constant? Because alpha is a constant, c also is a constant, e also is a constant. So a constant power to constant, it can be a new constant, let's say a. Okay, so right, we simplify here. Negative alpha v equals to a e negative alpha t minus g. Then v will be g over v. I write this term first because negative negative become positive. Then minus a over alpha e negative alpha t. So divide your negative alpha to the right hand side. Then we compare. Compare with your answer. So we have the term of g over alpha. So this term we haven't, but e power of negative alpha t we already getting. So the next procedure is going to find out the constant a here with the initial value. So the initial value we have is when t equals to 0, velocity will be v naught. So substitute v naught here. E power 0 equals to 1. So we find out what is our a. Alright, so we multiply back alpha to the v naught. So a will be equals to g minus alpha v naught. Then we can substitute back to our solution. G over alpha minus A is G minus alpha V naught over alpha E negative alpha T. Then we try to simplify until we can get this form of the term. So you will need to divide your alpha one by one. G divide alpha. And then second term, alpha divided by alpha, it can be simplified, leaving V naught. Then we look at the answer again. So we managed to show. Then for the question B, find the difference in velocity of the parachutist from the feet and the 10 minutes. So by using the solution given, you need to find out what is your velocity when t equals to 5 and t equals to 10. Find out the v here. So the differences of the velocity, we can take v at the time of 10 minutes and velocity at the time of 5, we minus. So minus the velocity at the 5th minute. Yes. So from here we can identify that G over alpha minus G over alpha. Then remaining term here, we can take out negative become positive. So we can see we're having a coefficient G over alpha minus V naught, G over alpha minus V naught. So this constant we can factorize out. When we factorize out, remaining will be negative E power of 10 alpha. This one plus E power of negative 5 alpha. Then when we come to part C, find the velocity of the parachutist after a long period. Means t will be tends to be infinity. So what will be the velocity? We substitute back our formula here. V equals to G over alpha minus G over alpha minus V naught, then E negative alpha T. So E power of negative, we can rearrange back E to the power of alpha at the denominator. T is infinity. So from here, we operate the infinity alpha times infinity, it tends to be, it will approximate to infinity. Then when exponential power infinity, because you power a big number, of course your number will be getting bigger. Then 1 over a bigger number, it will tend to be 0. So therefore, for this term, it will be tends to be 0. Lastly, velocity remaining will be tends to be g over alpha only. Because 0 times anything here is 0. So lastly, your velocity will be approximate to g over alpha.